All right, cumulative review 3, problem 19. As we read the problem, I don't see anything about compounded or half-life. I just see decreases, so that tells me it's a decay problem. Here's our equation for decay. Got our original amount, all right? Our percentage rate, which we had to convert to a decimal value, and then we're doing this for 5 years, so to plug in the time, crunch those numbers, and we get about 114,542. Now here we see, in problem 20, we see the compounded word. Now we got to be careful. We need to know if it's a compounded interest problem or a compounded continuously. If it's compounded continuously, it will say continuously. This one says compounded quarterly. That's 4 times a year. All right, so the number of times it's being compounded is the 4. All right, that's what the n represents, number of times being compounded, 4. All right, initial amount, percentage rate converted, number of times compounded, raised to the power of the number of times compounded, and the time of 10 years. Crunch all those numbers, and you get this. 21. All right, there's our compounded continuously. That's when we use the E value, okay, the Euler's number. Okay, so we have this equation. P is like A in the last ones. It's the original amount, known as the principal, right? That's our 3,000. And we have E raised to the power of R times T, the rate times the time, but we don't know the time. We're looking for the time. They give us the amount, though. How long is it going to take to reach the 5,000? So when does it equal 5,000? This is that log problem, all right? So we got to divide by the 3,000. This you can leave it as 5,000 over 3,000 if you wish. I chose to simplify it to 5/3, all right? And then I changed it to a log problem, put the log out front. I dropped that T down, but I decided, because it's an E, I decided to leave the 0.04 up top there. All right, if you wanted to bring the 0.04 down, you could. That just means you're going to raise E to the first power. And anyway, I finished up the problem by dividing. I didn't show the step here, but I divided by log of E to the 0.04 on both sides, and that's how I came up with this answer. 22. There's our half-life problem. All right, I didn't underline it, but that's half-life. All right, here's the equation. Right. Initial amount, 10, half, raised to the T over H. This is the time over the half-life amount. All right, the half-life amount, let's see, it says the half-life of medicine is 2 hours. So that's why the H is 2. All right, and then the time you're looking for is after 6 hours, so 6 there. Plug all those numbers in, and you get this. 23. Rewriting it in log form. Whatever your base is, that's what your subset number is. Okay, so you'd say log base 2, drop that down, and then bring our 8 over. Whatever the exponent is, that's what you're going to set it equal to, your x, I guess, if you will. All right, and then going back the other direction for problem 24, take the log expression and convert it back. Right, so take your subset number, that becomes your base. Whatever it equals, it becomes your exponent. And that other number is what it equals. Right, so 23 and 24 are just flip-flops of each other. 25, solving for x. So 25 and 26, it's basically 23 and 24 in the fact that one's exponential and one's logarithmic expressions. Only in these cases, they're equations, and so we're solving for them. So what I did here is I brought this exponent down out front, and then I changed this to a log. Kind of went about it a different way just because I feel like this is easier for me. Drop the exponent down out front, change this to a log, change this to a log. And then to solve for x, it's just a matter of undoing the operations. So I divided by log of 3 on both sides. Right. Came up with that answer, which was just 5. 2x equals 5. And then divide by 2, and you get x equals 5 over 2, or 2.5. 26. Right. I converted this back to exponential form. Remember that your subset number becomes your base. Raise it to that exponent, that power, so 2 to the 4th. And then we can just drop the log and keep that expression. Now 2 to the 4th equals 16. So I changed that to 16 and just solve the equation. We get 13.